Hey kiddos, today we are going to be talking about sketching graphs from a data table. So what we're going to focus on first is looking at the key features of an equation that let us know what the graph is supposed to look like. So here we have four different equations and we have to categorize them based on whether we think the equation is going to result in a linear, quadratic, or exponential graph. So the way that we do this is by looking at the equation itself and then determining whether or not that equation is going to be linear, quadratic, or exponential when we graph it. Now let's talk about the three different options we have. A linear graph, the key word here is line. Okay, that means that when we graph this, the graph is either going to look like this, or a sketch could look like this depending on the slope. And the key feature here that we're looking for is we're looking for regular x. Now remember, linear usually comes from y equals mx plus b, and that's in slope-intercept form. And so what we're going to do is look for regular x. Now quadratic, we have our key letter, the u, because that's what the graph looks like. It's a parabola, and so it's going to be a u shape. And what we're looking for to determine if something is quadratic is we're looking for x squared in the equation. Exponential, okay, the key word here is exponent. And what we're looking for is a key feature in the equation of a number that's raised to the power of x, where x is actually our variable. And remember, exponential is that Superman curve where it starts off small, but then it starts to curve up like that, okay, or it can curve down like that. So those are the graphs that we're going to be working with today. Now let's look at the equations down here and let's figure out which one each represents. Okay, so number one, y equals 6x plus 9. I see regular x here, and so I know that this is going to be a linear graph. Number two, y equals x squared plus 3x minus 7. I have x squared here, so I know this is quadratic, and that graph is going to be a parabola, so this is quadratic. Number three, y equals 5 to the power of x minus 10. Again, I have a number raised to the exponent, the power of x, and so this is going to be exponential. And then last, I have y equals negative 3 over 7x minus 2. Don't let that fraction throw you off. This is still regular x. This is y equals mx plus b, and so that is going to be linear. Okay? Now, the reason this is important, the reason it's important to be able to identify based on the equation what the graph is going to look like is because when we're graphing from a data table, some of the time we don't really know what the graph is supposed to be when we look at the equation. So having an idea of if the graph is supposed to be linear, quadratic, or exponential will give us a really good clue on whether or not we're making mistakes with our math when we're figuring out the points from the data table. So if I know based on the equation that it's supposed to be linear, when I go to graph it, if it comes out as a curve, I know I made a mistake somewhere, either in the data table or in graphing the points. So that's why it's really, really important to have an idea before you start the data table, before you start sketching the graph, what the graph is actually supposed to look like. And the way we can do that is by looking at the equation. Okay, so our focus today is going to be graphing from a data table. So this is a really, really foundational skill because you can use this no matter what the graph looks like. Okay, no matter what kind of equation you have, you can always plug in values. Okay, let's get down to those problems in our notes. Okay, sketching a graph from a data table. So what we're going to do is we're going to find some points on the graph, and then we're going to sketch them. So we're pulling in the skills that we learned the last time we were in class, where we were plugging numbers into an equation to see if the point was on the line. We are going to plug in values for x, and then we're going to find the corresponding y to get ordered pairs so that we can graph the line or curve, depending on what the equation is. Okay, so here's our process. We're going to find points on the graph by choosing numbers for x. We're going to plug those into the equation to get our y values, and that will give us our ordered pairs. When we graph the ordered pairs, it will allow us to sketch the graph. Okay, to make our lives easier, I'm going to go ahead and choose these values for us. We're going to use -2, -1, 0, 1, and 2. That will give us a pretty good idea of what both sides of the graph look like from the negative perspective, -2 and -1, 0 and the positive 1 and 2. It will also allow us to work with some pretty easy numbers. -2, -1, 0, 1, and 2 are relatively small numbers, and so plugging them into any equation, no matter how complex, will usually give us a really easy time. Okay, here's our first example, even though it says example 2, don't mind that. Now, what we're going to do first is we are going to look at the equation and we're going to make a guess about what the shape of the graph is going to be. So looking at this equation, y equals -3x plus 2. Okay, again, thinking about what we talked about in that warm-up, I have a -3x, just regular x, plus 2, that's y equals mx plus b. So this is going to be linear, and the graph is going to be a line. Okay, so because the slope is negative, the line is going to look something like that. Okay, so now what we're going to do is we're going to plug numbers into that equation. So I'm going to take all of my x values here, -2, -1, 0, 1, and 2. Now again, those are our x values. So when I look at my coordinate pair, those are, or not my coordinate pair, my ordered pair, those are my x values, -2, -1, 0, 1, and 2. Now to get the y value, I have to plug those into the equation. So what I'm going to do is I'm going to write the equation down, but instead of x, I'm going to leave a little blank space there so that I can eventually plug a number in. Okay, and I'm going to do that all the way down. I like to set this up first so that I don't have to worry about doing it as I'm going along. I'm going to set up all of my equations, and then I'm going to go in and do the work. Okay, it's the same equation all the way down. That pen's getting away from me. There we go. Okay, and now what we're going to do is we're going to take our x values, and instead of x, we're going to plug in those numbers. Okay, so instead of x for the first one, I'm plugging in -2, then -1, then 0, then 1, and then 2. And now I'm going to work out the math in my head or using a calculator just by going through and following my order of operations. So -3 times -2 is +6 plus 2. That's going to give me 8. And that will be my y value for this ordered pair. So that's -2, 8. And I'm going to go ahead and graph that. So starting at 0, I go left 2, and I go up 8. Okay. Next line, -3 times -1 is +3 plus 2 is going to give us 5. So my ordered pair here is -1, and the y value is 5. So starting at the origin, I go left 1, up 5. Okay. Next line, -3 times 0 is 0 plus 2. 0 plus 2 gives us 2, so my ordered pair is 0, 2. So starting at the origin, I stay at 0, but I go up 2. Next line, -3 times 1 is -3, and I'm going to add 2. This is a tug of war problem, so the -3 is bigger, so the answer will be negative. 3 take away 2 is 1. So my ordered pair is 1, -1. That means starting at the origin, I go right 1 and down 1. And then the last line, -3 times 2 is -6, plus 2, again another tug of war. -6 is bigger, so it's going to be -4. 2, -4. So I go, starting from the origin, right 2, down 4. Okay. And now that I have these dots, all of these points on my graph. I'm going to connect them, trying to do better than me, hitting all the points. And we can see that it pretty much matches up exactly with what I thought the graph was going to look like. Okay, so again, that's why it's super important going into a problem like this, that before you start working on the problem, you make a guess about what the graph is supposed to look like, so you know if you made a mistake when you actually are graphing. Okay, we have one more example. Our next example is going to be y equals 2x squared minus 5. So again, we're looking at this equation and we're going to make a guess about what the graph is supposed to look like. Now, you can tell by x squared that this is quadratic. And so it's going to be a U shape called a parabola. So the graph is going to look something like that. Okay. Now again, we follow the same procedures. We have our x values. So those I'm going to circle in purple just so we know where they're at. I'm going to write those down already in my ordered pairs. So -2, -1, 0, 1, and 2. Now we need to find our y values. So to do that, I need to plug numbers into the equation. So I'm going to go ahead and write that out. 2, I leave a blank space, but I'm going to square that. So I got to be really careful and make sure I include that little exponent there, -5. 2, parentheses, squared, -5. Okay. I know this is meticulous, but we're setting up our problems so that we don't make silly mistakes later. Okay. We're giving ourselves a nice structure that we can plug numbers into. Squared -5. Okay, and now we are going to plug the x values in to those parentheses. So -2, -1, 0, 1, and 2. Okay, now this is super important. Order of operations is very, very important when you're doing problems like this. So you have to remember PEMDAS. We're going to do our exponents first, then we're going to multiply, then we're going to subtract. Okay, so I'm going to start off by keeping the 2. -4 squared, -2 squared is -2 times -2, and that's +4. And then I bring down the -5. Okay, now if you need a calculator, please feel free to use one, but we're going to try to do this all in our heads. So 2 times 4 is 8, -5 gives us +3. And so that is my y value. -2, 3. I'm going to graph that. Starting at the origin, I go left 2 and I go up 3. Next line, keep the 2. -1 squared is -1 times -1. That's +1 -5. So 2 times 1 is 2. Take away 5 is -3. So my ordered pair is -1, -3. Starting at the origin, I go left 1 and down 3. Next line, keep the 2. 0 squared is just 0 times 0. That's still 0. -5. 2 times 0 is 0. Take away 5 is -5. So my ordered pair is 0, -5. Starting at the origin, I stay at 0, not going left or right, but I go down 5. Next line, keep the 2. 1 squared is 1 times 1, which is 1, -5. 2 times 1 is 2, -5 is -3. So my ordered pair is 1, -3. Starting at the origin, I go right 1 and down 3. And then my last line, keep the 2. 2 squared is 4, -5. 2 times 4 is 8, -5 is +3. So my last ordered pair is 2, 3. Starting at the origin, I go right 2 and I go up 3. Now, when I connect these, I'm going from the left to the right. So I'm going to try to do this and hit all the points. I'm going to scoop down and then scoop back up. And it does make that U shape that we thought it was. That's our parabola. And so based on our guess, the graph matches exactly what we thought we were going to get. So if you don't get something that you know you should, for example, if you know the equation is linear and you get a curve, or you know that the equation is quadratic and you get a line, it means you made a mistake with your calculations. And so having an idea of what the graph is supposed to look like before you do the data table is really helpful because it can help you to realize that you made a mistake with the math somewhere.